Hi YouTube friends, I'm Teacher Regy Safadão, and today we are going to talk about the thermolinear expansion. Are you ready? So, join us! Hi YouTube friends, I'm Teacher Regy Safadão, and this is our class number 2 of 6, talking about thermology. Okay, let's see our opening. Well, as we already know, our channel is Mathematics Without Frontiers, and here we have classes of physics, mathematics and English in two versions, one in English and the other one in Portuguese. Go there, visit us. Our video classes in Portuguese are excellent. Okay, as I told you before, today we're going to talk about thermology, thermolinear expansion. Okay, so are you ready? Let's see our first question. Pay attention. An aluminum wire is 20 centimeters long at a temperature of 20 degrees centigrade. If it is exposed to a temperature of 45 degrees centigrade, what is its linear expansion? Given alpha of the aluminum is 22 times 10 to minus 6 over degrees Celsius. All right? Well, here we have an illustrative picture. And what was given? The initial length, 20 centimeters, the initial temperature, 20 degrees Celsius, final temperature, 45 degrees Celsius, and alpha of the aluminum. Okay. Say, what is required? Delta L, okay, the linear expansion. Okay, so let's change in temperature. It is always done. We are going to solve this problem in 2 steps. I used to say this, we are going to solve in 2 steps in a couple of minutes, all right? So delta T is always calculated. I used to calculate it in advance, all right? I used to calculate it before everything. So delta T is always TF, final temperature, minus TI, the initial temperature, okay? And also then we are going to find the linear expansion, applying the formula. Delta L is alpha times the initial length times delta T, okay? That's why I used to calculate delta T first, okay, in advance. So let's do the calculation of delta T. Delta T is 45 minus 20, okay? Always the final temperature minus the initial temperature. Well, so delta T is 25 Celsius degrees, all right? So since we have this value, we are going to replace at the formula and do the calculation. So delta L is alpha. Alpha is 22 times 10 to minus 6 times initial length is 20 and the change in temperature is 25. So you have already realized for sure that 22, 20, and 25 were given in yellow. You see why? Because I'm going to multiply them first. I'm going to do these products first. Okay, so 22 times 20 times 25 is 11,000. Okay, so this is why it is in a different color in order to make you see it better. All right, so 22 times 20 times 25 is 11,000. Now see the way I'm going to do, the way I used to do. All right, now 11,000 is going to multiply by 10 to minus 6. How I used to do this? Well, the point is right here, so I'm going to move the point 6 spaces to the left. Okay, why 6 spaces? Because I have here minus 6, so it means I have to move the point 6 spaces to the left because it is negative, it is minus 6. If it were positive 6, I would move to the right, but it isn't, so I'm going to move the point 6 spaces to the left. So let's count with me. 1, 2, 3, 4, 5. 5. I need to move one more. So pay attention. So delta L is, so I have to move one more space. So I was here in 5, now 6. So the point is going to be here. So fill the space with zeros. So 0.011 centimeters is the linear expansion of question number 1. All right. So far, so good. Let's go to question number 2. 1 is done. Let's see question number 2. Here it is. During an experiment, a massive iron ball was heated from 15 degrees Celsius to 65 degrees Celsius. Knowing that the initial length of this ball was 40 feet and the linear expansion coefficient is 1 point times 10 to minus 6 over degrees Celsius, find the iron bar length after the experiment. Okay, a picture. What was given? Initial length, 40 feet, initial temperature, 15 degrees Celsius, final temperature, 65 degrees Celsius. And the alpha of the iron is 1.2 times 10 to minus 5 over degrees Celsius. Okay? And, okay, required is the final length. So delta T, as I told you, every time I used to find the change in temperature first. And what formula we're going to apply for solving this question number 2? This one, because every time I want to find the final length, I use this initial length times 1 plus alpha times delta T, okay? So let's find delta T separately, okay? Let's see. So delta T is 65 minus 15, that it is 50 Celsius degrees. All right. So now let's replace the values. I used to say let's plug the values into the formula. All right. So we have the given values right here, and delta T was already calculated. Okay. So we have here initial length is 40. Alpha is 1.2 times 10 to minus 5, and delta T is 50. Okay, so you see it is in brown. 1.2 is going to multiply 50. Only these for this moment. Okay, so I have that LF is 40 times 1 plus 60. Why 60? 60 is the result of 1.2 times 50. It is 60. Okay, now see what I'm going to do. You see here 10 to minus 5. I'm going to multiply 10 to minus 5 by 60. It means that I'm going to move the point 5 spaces to the left. Okay, the point is right here. So let's see, 1, 2. Okay, I need to move 3 spaces more. Okay, so I was here 2, 3, 4, 5 spaces. So fill the blanks with zeros. So now I have 0.0006. This 0 here, forget about it. Okay, now we have to add it 1 to add up. 1 plus 0.0006. This number 1 is going to be written right here. Okay, let's do it. So the final length is 40 times 1.0006. Now let's do this multiplication and we have the result. So the final length is 40.024 feet. All right. So question number 2 is done. Let's see question number 3. Here it is. So far, so good. Let's see question number 3. A concrete bridge is 800 meters long. Find its linear expansion when the temperature goes from 15 degrees Celsius to 35 degrees Celsius, given the alpha of the concrete is 13 times 10 to minus 6 over degrees Celsius. Okay, a picture, an illustrative picture of a bridge, a concrete bridge. And what was given, the initial length is 800 meters. The initial temperature is 15 Celsius degree or degrees Celsius. And the final temperature is 35 degrees Celsius. And alpha of the concrete is 13 times 10 to minus 6 over degrees Celsius. Well, let's find delta L, okay? Well, let's see. So as I told you, I used to find the change in temperature before every time. This is the first calculation I do, all right? So TF minus TI. And also I'm going to show you the formula I'm going to apply. Delta L is alpha times initial length times delta T, okay? So let's find the delta T before everything. As I told you, I used to solve this kind of question in 2 steps. Okay, in a couple of minutes, we do this. Let's see, 35 minus 15 is 20. So delta T is 20 degrees Celsius. Okay, or Celsius degrees. Well, so let's plug the values into the formula. That's right. So delta L is alpha, 13 times 10 to minus 6. Initial length is 800, and delta T is 20. You see? I wrote the numbers in blue, all right, because I'm going to multiply 13 by 800 by 20, all right? So let's do this. 13 times 800 times 20 is 208,000, okay? Now, see, I have to multiply by 10 to minus 6. What it means? It means that I have to move the point 6 spaces to the left. All right, so the point is here. Let's move 6 spaces. Let's see, 1, 2, 3, 4, 5, 6. You see? See, so delta L is 0.208 meters. Okay, so we have finished it. This is the result. This is the length expansion of that bridge. Okay, so far so good. Let's see question number 4. All right, here it is. Stainless steel cord is 24 inches long at 10 degrees Celsius. Find the length of it when the temperature reaches 80 degrees Celsius. Knowing that the linear expansion coefficient of the material is 19 times 10 to minus 6 over degrees Celsius. Let's see a picture. What was given? Initial length, 24 inches. Initial temperature, 10 degrees Celsius. Final temperature, 8 degrees Celsius. And alpha of the steel is 19 times 10 to minus 6 over degrees Celsius. Okay, so required is the final length. As I told you before, let's find the change in temperature. Final temperature minus initial temperature. I'm going to show you now the formula I'm going to apply for solving this question. You see? So final length is the initial length times 1 plus alpha times delta T. Okay? So let's plug the values into the formula. So, okay, let's find delta T. Delta T is 80 minus 10. That gives 70. So delta T, the change in temperature is 70 Celsius degrees. Now, so yes, let's plug the values into the formula. Okay, we know that the initial length is 24. 1 is here, plus alpha. Alpha is 19 times 10 to minus 6. And delta T is 19. We have already found it. Okay, you see that it is green. It is in green in order to make you pay attention that now I'm going to multiply only these numbers. Okay, so 19 times 70. Okay, so it is 1,330. Okay, so see again what I'm going to do. I'm going to multiply 1,330 by 10 to minus 6. What it means? It means that I'm going to move the point 6 spaces to the left. See, the point is here. 6 spaces to the left. Count with me. 1, 2, 3, 4. Let's go on. 4. I was good. 5, 6. Can you see? The point is right there. So now fill in the blanks with zeros, and I have 0.00133. Now I'm going to add up with this one here. So 1 plus 0.0013. What it means? It means that this number 1 is going to be written right here. Okay? This way. You can see? Now, to finish my question, Okay, and give the result. The final length is 24 times 1.00133. So the final length is 24.032 inches. Okay, this is the answer. This is the final answer. Okay, very good. Now, obviously, let me move my window from here. Okay. Well, our special thanks. Thank you very much for watching our video until the end. It is quite very important for our channel. Subscribe our channel as well. Share this video with everybody you love, your friends, your siblings, your neighbors, okay, your classmates, okay? And of course, give us your like. It is really very much important to us. Thank you very much. See you. Have an excellent week. I'm your teacher, Regy Safadão. Bye.
That's all, folks.